Hello, everyone. I want to take a little time to go quickly over this sample test for test one that I handed out. I'll post these written out solutions online once I have them done, as well as posting the video. If you don't have this, I did send it in an email as an attachment, but if you don't have that email, don't have that attachment, lost it, whatever, there's a link to it on my website in the same place where you will see the solutions and where you found the link to this video, unless you got it from an email I sent. One big recommendation I put on the email, but I want to emphasize, is when you go through a sample test, make sure you do it once you really have everything else that you want to study done, so that you can go through this in as test-like way as possible. If you're used to doing homework where you're looking things up a lot, or where you have music, or while you're watching TV, or any of those things, taking a test can then be very foreign to your thought process. And it can make things you knew how to do suddenly seem like you don't know how to do it. So you can really help find that out by going through at the end when you're just getting ready to take the test, a day or two before, go through and do stuff in as test-like a way as possible. No music. Do it all at once. Don't look things up. Sit in an uncomfortable chair. If you get stuck on a problem, don't go figure out why. If you get stuck on a problem, go on to the next problem. Give yourself a time limit. This is a little bit longer than your test will be, so maybe an hour and a half to 2 hours. And if you have to go longer, go longer. Just take note of what's taking you a long time and what's not. That can really help point out to you things that you thought you knew how to do, and you do know how to do, but isn't coming forward to you on a test, so you can figure out why that is and fix that. You'd much rather have those problems become apparent when you do a sample test, as opposed to have those come up for the first time on your actual test. If you do that and then work through the stuff again and then want to do it later, you can find questions exactly like these in your textbook. There's an online tests, which are a little bit different, but same kind of material. Use them to make up your own tests of 10 to 15 questions and take them again. Making up your own tests is a wonderful way to study in preparation for math. Okay, so a little 2-minute and 45-second intro. Let's look at some of these problems. I'll probably have to split this video into a couple pieces so they fit on YouTube, so look for that. Okay, the first thing you're asked is, given the function f of x equals 2x squared plus x, you're asked to find the average rate of change for that function. Now we need some values to find that rate of change between, and you're given x equals -1 and x equals 2. Now the average rate of change formula I'll probably put on your exam, so if you don't remember it, that's okay. And I guess I should say I will put on your exam. But really, the thing to remember about average rate of change is it's just slope. Slope is usually y2 minus y1. Average rate of change just puts that in function notation. The function at x2, that's just your y value, minus f of x1, that's a y value minus another y value, over the difference in the x values, y2 minus y1 over x2 minus x1. That's slope. Now they're calling it average rate of change. Well, that's just because it's supposed to apply to nonlinear functions. This is a nonlinear function. So we got to plug in 2 and plug in -1. So what, 2 times 2 squared plus 2? It's a lot of 2's. What, 4, 8, 10. 2 times -1 squared plus 2 is what? 2, it turns into a 1 times 2 plus 2 is 4. So f at 2 is just, if it helps, put a x1 and an x2 there. So f of x2 is 10 minus f of x1 is 4 over 2, x2 is 2 minus x1 is -1. So we get what here? 6 over, that turns into a 3, so 2. So your average rate of change for this function is 2. And, just for those of you who are curious, you are looking at a parabola. This is certainly a parabola. And we've taken the slope of the line between the values at -1 and 2, and the slope of that secant line, as it's called, is a slope of 2, average rate of change for that function between -1 and 2. So that's number 1. Number 2 is actually a surprisingly similar question. You're given the same function, 2x squared plus x, and you're asked to evaluate the difference quotient. Now, just like the average rate of change, I will give you the form for the difference quotient. But again, just like the average rate of change, this really is slope. So y value minus a y value. The difference between the two x inputs is h. That's the difference between the two x inputs. So this is really y2 minus y1 over the difference in the x's. Change in y over change in x. It's another version of slope. And it, again, is a general, let me fix the focus there, a general way to handle finding slope for things that aren't linear. For those of you going on to calculus, this is actually the basis of differential calculus. Sorry, let me fix that. This difference quotient. Let me see if I can stop that from happening. That didn't help. There we go. So again, this is really the basis for differential calculus. So you'll be seeing this a lot more as you go on. But if we're trying to evaluate this difference quotient, we're supposed to put f of x plus h here. Now, if I asked you to find f at 5, you'd plug a 5 in. If I asked you to find f at -10, you'd plug in a -10 for both of the x's. F of hippopotamus, you'd put a hippopotamus in for those x's. F of x plus h, put in an x plus h. 2 times x plus h squared plus x plus h. That's this f of x plus h. That piece minus, here again, f of just x, well, that is f of x. Notice the brackets are going to keep my signs straight. Over, this h isn't going in there because it's not f of h, so just over h. Separate that off, excuse me. Now the goal for this, simplifying these, is really always to get rid of this h. In calculus you'll see why. Our goal is eventually to divide by this h. And we can't divide by 0, and we want to eventually let that h be 0, so we want to cancel this h out. But really just simplify this, and you'll see that happen. Foil that out and distribute your 2, so 2x squared plus 4xh plus 2h squared plus x plus h minus 2x squared minus x, make sure that distributes, over h. Notice everything without an h in it cancels. You're left with 4xh plus 2h squared plus h all over h. And divide that h up into each term, and you get a nice 4x plus 2h plus 1. And again, in calculus you'll play more with this, but this really does give you a formula for slope of tangent lines to our parabola. You plug in h equals either 0 or a very small number, and the x value at which you want the slope of the line tangent to the curve, and you have the rate of change for this function. We're really using this as a tool to practice working with your functions. But it's nice for those of you going on to calculus to know that's going to be a bread and butter tool once you get there. Okay, number 3. So you're given a graph and asked to find where it's increasing, decreasing, and the extrema. So your graph, let's see, we go up, increase until -3, 2. It decreases down to -1, -3, increases again to 2, 1, decreases to 4, -1, and then increases for the rest of its domain. Now, I talked through that as I drew it, but just to be clear, it's very easy to look at a point like 4, -1 and look at it as going up this way and up that way. But that's really not what we're talking about when we talk about increasing and decreasing. You're really talking about what the y values do, what the function does, as the x's go from left to right. So as we're going in this direction, it's kind of silly, but I always imagined a little hiker on this thing. And the hiker is going this direction. You're really asking, when is he going uphill? And when is he or she going downhill? So as we go in this direction, this is all uphill. So that's increasing from -infinity to -3. At the 3, -3, we're not increasing nor decreasing. We'll stop at the top of the hill for a moment. We're also increasing from -1, so union the sets, -1, all the way to 2. All of these x values in here are making us increase. So from -1 to 2, the function is increasing. Unioned with, from the x values from 4 on, from 4 to infinity, all of those x values cause the function to increase. So those are the region in which it's increasing. If you want to know where it's decreasing, decreasing is the rest of it. We are decreasing, we're going downhill from here to here. Again, as we travel in this direction, everything is always left to right. So we're decreasing from -3 to -1. Unioned with, we're decreasing from 2 to 4. And that's your region of decrease. Notice it's all, your answers are really x values. These are the x values, the parts of the domain in which the function is either increasing or decreasing. How high it increases or decreases, how fast it increases and decreases is not what you're being asked. You're just asking where in its domain is it going up and where in its domain is it going down. Oh, we have to answer about extrema there too. Remember extrema are our maxes and mins, and they can be relative or absolute. Because this function goes up and up and up, it doesn't have an absolute max. Because it goes down infinitely, it doesn't have an absolute min either. But relative or local maxes and mins are happening here. That point, that -3, 2, is a relative maximum because it is the maximum point relative to everything around it. Everything really near this point, that's the highest one. Down here, everything near that point, this -1, -3 is the lowest point relative to its little neighborhood. So -1, -3 is a relative min. That -3, 2 is a relative max, so is the 2, 1, as is 2, 1, for the same reason. It's the highest thing in its little area. That -1, and the 4, -1 are again both minimums, relative minimums, because they are the minimum for their little area. To be an absolute or global max or min, you have to be bigger than everything on the graph. This point isn't lower than everything on the graph because this is going down and down infinitely. So there can't be any lowest. So there are no absolutes. Make sure you look over your section on determining absolutes in case the graph you get on the test has some. Okay. Number 4. You've got 4 through, was it 8? No, 4 through 7 that are building lines. You probably won't have that many line questions on your test, but I want to make sure you guys are good with graphing your lines. We're going to rely on that later on. So I want to make sure we have these skills. So I've kind of had this build up. The first one, you're wanting to make a line where your slope is 2/3, excuse me, and your y-intercept is the point 0.02. And you're asked to write in slope-intercept form. Well, the nice thing, slope-intercept form, that's the y equals mx plus b form. If we know that form, hopefully we remember that the m is our slope. We use m, by the way. It's the first letter of the French word for ascend. That's why we use it for slope, based on the French. And that b is our y-intercept. And it's a b because sometimes people use ax plus b, and it's just the next letter in the alphabet. So we're told our slope and our y-intercept, so we just put them in. So y equals 2/3 x plus, and the y-intercept is the value that goes with the 0 for x, so it's just the 2. And that question really is that nice. Now, I wouldn't, if I were you, expect to be given both the slope and the y-intercept, but I want to make sure we know how to handle it when we are. Really, those are the two things we're looking for in any linear problem. Tell me what the slope is, figure out what the slope is, and figure out what that y-intercept has to be. But hey, if we're lucky enough to be told them, great. And sometimes that happens. You know, you're charging 25 bucks an hour, that's your slope, and you charge an extra 50 bucks just to show up, that's your start value, your y-intercept. It makes a line very quickly. So you'd be surprised how often it just comes to us in that form. Number 5 makes you do a little bit more on your own. So you're given still the same slope, m equals 2/3. But now we're not given the y-intercept. We're given an arbitrary point. I'm going to call it x1, y1, because they're actually known values. Given an actual point of -1,5. So careful. The other one we were given this 0, 2, and we used that 2 for the y-intercept, but that's because it went with the 0. It was an actual y-intercept. This isn't a y-intercept anymore. It's just a y value. It's the y value that goes with -1. So we can't just plug that 5 in the way we did the 2. Now we have a couple choices here. We can either use point-slope form, and if you like point-slope form, please feel free to use it. But if we just want to use the slope-intercept form, we can. Again, the slope-intercept is going to look like y equals mx plus b, where m, again in this one, we're given that the m is 2/3 x plus b. But we're not told what the b is. We have to figure it out. Again, it's not the 5. But this point, this -1,5, does tell us that when x is -1, y is going to be 5. So we should be able to put those points in. 2/3, when the x is equal to -1, plus whatever this b is, it's going to equal 5. And we can use that fact to figure out what this b has to have as a value, just by solving this equation. You got 5 equals -2/3 plus b. I'm going to multiply by 3. A little bit of solving here. 15 equals -2 plus 3b. You could also add the 2/3 over if you want to deal with the fractions. It's up to you. Add the 2 over. 17 equals 3b. Divide by 3. So 17/3 equals b. So now we know what our y-intercept is. The y-intercept is the point 0, 17/3. So if we wanted to build our line, go back to the y equals. We know the slope was 2/3 because we were told that. And we now know the y-intercept is 17/3. So we have our line. Okay, for number 6, I think I'm running into my 20-minute limit. So for number 6, I'm going to do a separate video. Look for that. It should be over to your other side on the links. If not, I'll send a link to it. and I'll see you there in a minute.